Hi everyone, let's go through Wednesday's quiz. And so I'll start with the tracing of the conditional statements here. So let's open the debugger and set a breakpoint and see what happens. All right, so we're looking at Friday, and this person is having a birthday and has elite status. So it is this person's birthday, so we're going to add 50% to that discount. And then notice the next thing we'll run is the following if statement, right? Because each if, as opposed to an else if, starts a new chain. This person does, in fact, have elite status. So we run the next line inside that if block. Now, here's the thing to notice, right? Here's something that a lot of students overlooked. This line of code is setting the discount. It's not adding to the discount, it's making the discount equal to 12%. So if we see right now, our discount is at 50% from the birthday, but when I run this line, that 50 is changed to 12. It's not added to be 62, but it's changed to 12. And then we move on to the next if statement, and it is not Tuesday. It's not Monday. So that leaves us with an answer of 12. So let's see what happens when we run the next one. So in this case, it's not a birthday. This person does have elite status, so we set that discount to 12. It is not Tuesday. It is Monday. So here we're adding to the discount. So 12 and 17 is 29. So we end up with a discount of 29%. Part 3, it's not a birthday. We have elite status. So here we are with that 12% discount at the moment. It is Tuesday. And so here is the other thing you've got to watch out for. This is a return statement. We're not changing the discount. We're not resetting the discount. We're just simply saying the answer is 0.2. At this point, we are done. The return statement gives the final answer for this function. No other code runs in this function. We go right to the end with an answer of 0.2. And then for the last one, this person does have a birthday, so we'll start out with a 50% discount. This person does not have elite status. Again, it is Tuesday. So regardless of the birthday or not the birthday, we're just returning 0.2 as the answer. All right, so let's see how those same principles apply to the other version of the quiz. All right, so we start out with a birthday, so we add that 50%. We do have an elite status. And again, like the other problem, we are not adding 10%. We are setting the discount to 10%. So we're changing the discount from 0.5 to 0.1. And it's not Monday. It is Tuesday, so we will add 0.15 to the 0.1 we already have for an answer of 0.25. Let's look at the second one. So again, we do have an elite status and a birthday. So we start out by setting the discount to 0.5, but then we replace it with the 0.1. Now today is Monday, and just like in the previous problem, we are now looking at a return statement. So whatever the value of discount is no longer matters because we're just returning 0.12. For version 3, same setup. We both have a birthday and an elite status. So we end up with a discount at the moment of 0.1 because we replaced the 0.5 with the 0.1. This time it's not Monday, it's not Tuesday, so our answer is just the 0.1. For the last one. So here we do have a birthday. We don't have an elite status, so we still are at 0.5, the 0.15 to the 0.5 to get 0.65. So you can see there are two main tricks in both of these problems. One is to recognize when we're resetting a variable as opposed to adding to the variable. and the other is to remember that a return statement gives the final answer for that function. All right, now let's look at the problems where we're tracing the loops. So again, we'll set up the debugger and start through. Now remember, with these tracing loops, of course, the function's not necessarily going to do what the name of the function says it will do, because then you don't have to trace the code. You just have to tell me what you think it should do, and that's not what we're going for on the quiz. All right, so let's see what actually happened. The name seems to imply that we're just answering yes or no. Are all the numbers in the list positive? But let's see where this code does something a little bit different. Now first, we're going to initialize this variable found negative to false, and then we'll work our way through the loop. So the first number is 10. That's of course positive. So that is not less than 0. So in the else block, we will set found negative to false. Well, it already is false, so that doesn't really have an effect. But we'll come back up to the next iteration of the loop. This time we're looking at the number negative 11. And of course, negative 11 is less than 0, so we will set found negative to true. And come back up for the third time through the loop. This time we're going to look at 12. 12 is not less than 0. So notice what's happening here. We have our local variable found negative. It is currently true. You can see that in the debugger window here in the upper right, but we are about to set it back to false. Found negative is just simply a variable, and we can assign and reassign it as many times as we'd like. All right, so the last time through the loop, we are looking at the number 13. 13 is not less than 0, so again, we are resetting found negative to false. There are no more elements in the loop. There are no more elements in the list, so we come down to the return statement, and we're going to return found negative, which in this case is false, as you can see up here in the corner, because that's the last value we set to that variable. When we looked at the number 13, we set that variable to false, so that's the answer the function's going to give. Remember, Python has no idea what the word all positive means. The name of our function has no semantic meaning. But the code we wrote is simply telling us whether the last value it looks at is true or false. So we can look at on the list here, we'll start that. Again, the same type of thing. We initialize found negative to false. The first value on the list is negative 10. So when we see that, we change found negative to true because we have found a negative. But when we go to the second element on the list, which is 11, that is not less than 0, so we're changing found negative back to false. And since the last two elements on the list are also positive, that found negative variable remains false, which is the answer given by the second call to all positive here. And hopefully at this point you can see that the third call to all positive will do the same thing. There is a negative value in here, negative 12, but the very last value is 13, so the very last time through the loop we'll end up setting found negative to false, and that will be the answer. I'll run this without the debugger, and we can see that the answer is still false. Put the debugger back on, we can look at the fourth one. Start stepping through. Found negative is false. You'll notice the first three numbers are all positive, so we just keep resetting found negative to false until we look at the last number, negative 13, which is of course less than 0. So we'll set found negative to true. Now this time, negative 13 is the last number on the list. So when we get to the return statement, true is the value that is in found negative. It just happens to be what we most recently set found -2. So in this case, it does give us a true response. So in this case, it returns true. Fifth problem here. Now, what makes this one interesting is there are no elements in the list. So as before, we'll start out by setting found negative to false, and then we get to the loop. Well, there's nothing in the loop, so what's going to happen? If there's nothing in the loop, then we just skip over the loop and go right to the return statement. So what's going to happen is it's just going to return whatever we happen to have last left in the variable found negative, which you can see up here on line 2 was false. So this invocation of the function will return false. So as a quick summary, remember you have to actually walk through the function and look at each line and figure out what each line does. Resist the temptation to take a shortcut to assume the function's going to do what it sounds like it should do. So if we come down to the other version, we have the same sort of situation where the function's name implies we're just counting how many odd numbers are in the list. But that's not exactly what this function is going to do. We have to look at it line by line again. So we'll start out by initializing odds to 0 and going through the list. So the first number on the list is a 1, which is odd. So we'll bump odds from 0 to 1. So far, so good, right? Now we'll look at the second number on the list, which is 2. 2 is not odd, so we come down to the else condition, and notice what happens here. We are resetting the value of odds to 0, so we're changing it from 1 back to 0. So we move to the third element in the list, which is 3. 3 is odd, so now odds is going to be incremented from what it is, which is 0, to 1. We come to the fourth element of the list, which is not odd, so it goes back to 0. And then the fifth element of the list, that's 5. It is odd, so odds gets bumped up from 0 to 1. That's the last element in the list. So when we return odds, we return the value that is currently in odds, which is just 1. So this call to count odds returns 1. Not 3. And the reason for that is every time we see an even number, that counter gets set all the way back to 0. So let's see what that implication is here on the second part. So again, we start odds at 0. The first value on the list is 7, which is odd, so we bump odds up to 1. The second item on the list is also odd, so we bump odds from 1 to 2. We just add 1 to the value that's already there. Now we see a 6. That is not odd, so now we set odds to 0. That counter goes all the way back to 0 because that's what line 7 says it should do. The next item on the list is 6, which is, again, not odd, so we set it to 0. Yet another 6, so yet another set of odds back to 0. All right, now we're looking at 5. 5 is odd, so we'll bump it from 0 to 1. Now we have a second 5, and that bumps it from 1 to 2. A third 5 in a row, which will bump it from 2 to 3. And that's the last value on the list. So we'll return the value that happens to be in odds at the moment, which is 3. So maybe you see the pattern here now. What this function actually does is it counts the number of odds, but it resets to 0 every time it sees an even. So this is really just telling you how many odds there are at the end of the list, how many odds there are since the last even. All right. The The next two aren't quite as interesting because there's only one number on the list. So in this case, it'll just return 0. So this time there's only one number on the list, which happens to be even, right? There's no odds on the list, so it's just going to return 0. Likewise, for the fourth one, there's only one number on the list, and it happens to be odd. So we initialize odds to 0. The first value on the list is 11, which is odd, so it gets bumped up to 1. There aren't any other values on the list, so the return value is just simply 1. And then for the very last one, again, it's an empty list. So what does that mean? Well, first we initialize odds to 0. And now what happens with the loop? Well, there are no elements on the list, so the code inside the loop never runs. We just jump down to that return statement and return whatever happens to be in odds, which is the 0 we initialized it to. So the answer there is 0. Now you may be wondering, why is the answer to this last one 0 as opposed to none? So remember, none is what you get when you leave a function without ever hitting a return statement. In this case, and in the one above, there is a return statement. This function always ends with the last line being a return statement. So we're not going to get a none. We are going to get a specific value returned, which will just happen to be whatever that variable was at the beginning of the loop. So odds was initialized to 0, and up here in the first problem, found neg was initialized to false. So hopefully that helps you get ready for this coming Wednesday's quiz. There will again be both of these kinds of problems on the quiz. So make sure you look through this carefully, ask any questions you need to so that you're well prepared.